How's it going, everybody? And welcome back to our Cisco Enterprise series. In this video, we're going to be taking a look at our first of many BGP best path selection options. And the first one is going to be wait, or we're going to be we set it inbound to affect outbound traffic. So the way that for policy application, this is kind of an important piece, and I'm going to do my best to try to remember to do this every time we cover a topic. Is anything that you apply inbound is going to modify routes as they leave the network. And then anything you apply outbound is going to apply to modifying routes into the network. So that's the big thing. It's the opposite action is going to be what keep that in the back of your mind is if you want to apply something in, it's how traffic goes out. If you want to apply how something goes out, it's how it comes in. So that is essentially where that comes into play. I don't want to go into any more of an in-depth discussion on that than I already have. So the first thing we're going to do is set the wait. And what we're going to do is I am going to go here on router 33. And right now, if we were to look at 33, and do a show IP BGP for something like quad 8, right? Quad 8, we're being pointed out 333.62, which means we're going directly out to ASN3. So what I'm going to do is I'm going to make for basically anything coming in 3362, I'm going to set a wait on this to be higher. So the higher the weight, the more preferred. So, right? Higher value is preferred, right? So what I'm going to do, actually take that back. I'm going to go on to gig 01. I'm going to set a weight here of like 100. And so any prefix that's learned from this path, and quad 8 is being learned both ways, right? And the reason why we're choosing to go this way is because it's the shortest AS path. So what I'm going to go do is on 33, I'm going to go ahead and the way you would do this, do show run section BGP is router BGP 65001, and then underneath the address family IPv4 for this particular peering, we're going to you can do a global wait. I believe it's the default. I think it's globally. Hold on one second. I think if you do default metric. Nope, that's for redistribution. Default. No. Default metric, that's redistributed routes. So I would have to go. There is a way to do this, and I forget. Sorry. It's BGP. Which one is it? Best path. No. So what I'll have to do is I'll have to attach I thought there was a global weight value. I thought there might have been, or a metric. There is a default metric for redistribution. So what I'll do first of all is I have to go create a route map for us. I'll type in route map, and we'll type in BGP weight, and then we'll do permit 10, and we'll say set the metric. Set the weight to be, we'll say 100, and then we'll get out of here, and then we'll do show run section BGP. We'll go back underneath here for this peering here, and we'll say route map, route-map, and we're going to say BGP weight. There we go, BGP weight, and then we're going to set that inbound. Okay, so we'll type in do show IP BGP, and so it doesn't take effect right away, so we'll have to type in do clear IP BGP star soft, and that'll get BGP to do a route refresh. And so what will end up happening is now for quad 8, instead of going this way, instead of going the shorter AS path, the wait kicks in, and now we're taking this path. Okay, so now if I was to go do trace to quad 8 numerically, I take 126 here, and then I go to 42 to 62 to here. So now if I go back to PC68 and scroll up here a little bit, we should have a trace route, right? So before we were taking 7 to 41, 41 to 25, 25, 57, 13, 33 to directly to 62, right? This was our original AS path. And then if I do trace route to quad 8 and type in yes, the path that I take now is I hit 33, but then I go to 26, then to 42, then to 62 to 10. So if I was to take the command out, type in no neighbor, and type in do clear, and then do show IPBGP, the command goes away. Now I go back to this, I do my trace route command again, trace route, and now I take a more direct path. So I gain 2 hops back. The bottom line here is that's how you would end up using wait. It makes it very, very simple to get the configuration in place. Locally significant, it happens on a per router basis. The way that I equate this is absolutely zero difference between how IGP does something and how BGP does it. Where if I'm dealing with OSPF or EIGRP, I would probably mess with the delay, but then not really the bandwidth, especially if I'm dealing with QoS. But if I'm dealing with the wait, I would, and as you saw it when we did this, it affected everything from that particular peering, right? Everything then had a weight of 100. Now, can I be more specific? I can. I can go in and be more specific to the prefix. I could be more specific to the AS path. I could do a bunch of different capabilities. So a simple test for this would be this. So we're going to keep the route map in place. So do show run section route dash map. So we have the wait process in place, but now what I want to do is if we're going to quad 8, then I'm going to do an IP prefix list, PL, for, we'll say Google, and I say permit 8.8.8.8/32 and hit the enter key, and then I do go underneath the route map here, grab this, and I type in match IP address and prefix list PL Google, right? And then I do show run section route map again. I have added this in. Now what will end up happening is I'll only affect this particular entry, right? So let's go ahead and do, now that I've done that, let's go do show run pipe section BGP. I'm going to grab this line again to this guy, and then I'll do route map, and it's going to be BGP wait, and then it's inbound. Do clear IP BGP star soft, do show IP BGP, and so now I'm only affecting this particular prefix. Now if I go back to here and I do this trace route again, now I'm taking that path, taking the 26. But if I, for example, went trace to 3162.6.1, so let's do another trace route to 3.1.44.1, the path that I'm going now is, for that particular path, I go 33 to 62, right? So it will depend on the prefix. I could do the AS path as well. The AS path is just about as easy to manipulate. So we'll do, the way we'll do that one here is, let me go back, do show run type section BGP, and we will pull this out again and do clear IP BGP star soft, do show IP BGP. So we're back to, it's good to, anytime you're doing a manipulation, clear the BGP database to get it back to where you want to, so you know the appropriate effect. So that's one thing I definitely do recommend as you're testing these out, is make sure you are testing every before and after so you can see the before and after. So the last one here is going to be the IP access AS path ACL. So it's going to be IP AS path access list. The AS path number, we're going to use 1, and then we're going to permit, and then we need to create a regular expression. So the regular expression is, I believe it's going to be $1 caret. I believe is how you do that. So when in doubt, always consult the Googles. So what I'm going to do is, we're going to do BGP regular expression AS path filter. So using regular expressions in BGP. So if you're ever not sure on this, you can always double check this. And the idea here is to only allow networks that originate from AS4 to enter R1. So I don't want to really do that. So, but this is going to be like okay, so it's caret $4. So no internet routes. So only allow networks that have passed through AS4 to enter AS3. So for so there's a bunch of different options that you can do. So this is where it becomes kind of useful to know how this works. So what I would do is, I would say, it says only allow networks that originate from AS4 to enter R1. So you're saying this is a starting character, the $sign is the end of the line, so you're matching only on 4. That's essentially what that says. Now there is a let's see, there is a regular expressions, like, there is a way to do this. There's an actual, like, Cisco document. So what do I want to do? If you want only the networks that have passed through AS4 to enter AS3 from router 3, you can apply that inbound filter. So deny networks originated in AS4. There we go. So, but to enter AS3 and permit all other networks. So I'm going to basically do $4 and I'll match 101. So, why does it I wish I could figure out a way to not have that happen. Got to be like a timeout thing, even though I'm actively inside the topology. So we'll do this. So on R33, I want to do, it's the other way around. So it's $4, I'm sorry, _4. In this case here, I want to do 101. That's the originating AS, 101 $. And then I'm going to do, so again, that is, we are looking for, if you want to, in this case here, we're deny or permit all the networks that originated in AS4. That's what we're looking for. So we'll do that, and then we're going to go do show run section route dash map, and then we're going to go back to BGP wait here, and we're going to say match IP. No, it's, what is the syntax? This is why you have Google at the ready. It is match AS path 1. That's right. match AS path 1 and do that. So do show run section route dash map. So again, we're going to match, and we're going to say no, match this. We want to match one or the other. Now, you can do more than one match in there. So if there's, let's say you're getting a bunch of subnets from a particular AS number, and you want to permit everything from the AS but only filter out specific prefixes, you can do that as well. So that's another feature if you wanted to do it that way. So now I'm going to do a do show run section BGP. And if you ever want to do show IP AS dash path, we're allowing 101. So let me go to here. The way that this should work is this. We're going to say route map and BGP wait inbound, do clear IP BGP star soft, and do show IP BGP. And that looks like it worked right there. We matched them 1-on-1. So you'll notice that anything that comes from 101, 3144 and 3166, 3162, right? So if I go back to PC68 and I do the same thing again, I do a trace route to this IP address. I'm taking that path, right? Now if I go to anything else, a trace route to 2.22.29.22, yes, I'm going to go out 30 to 62. So I'm taking this path right here, going to 62, then I jump over to 45, then I jump to 61, then I jump to, wait, hold on a second, I think I have a loop. 33 to 62, nope, that's right. Hold on a second. Do I have a 33 to 62, 62 to 45, 45 to 61, 61 to 29. No, that's correct. That's the correct AS path, or the correct direction. So you see how by manipulating that. Now I'm going to go ahead, and because 33, because we're matching on the AS path, but we've got additional subnets. So if I want traffic to go directly to quad 8, but take the directly connected networks. So these guys right here, 3162 and 3144. If I want to get them to go via 333, but quad 8 to go via 126, I have to put in a filter for that. And the way that I would do that is I'm going to go ahead and keep that in place, but I'm going to filter. So do show IP prefix dash list. Right, I don't have any filters for that. So what I'm going to do is I'm going to add a permit statement. So I'm going to keep an IP prefix list. Actually, I can do this Google. I can permit that one. So do show run section route dash map, and then I can go underneath here, and I can say match IP address and prefix list PL Google, and then I can do show IP BGP, and now we only affect the Google path, right? Now if I go back over here to trace route to 31441, now I take 333, 62, 62 to that direction. But if I trace route to Google, I take 126, 33, 26. So that's 3 different ways that you can manipulate it. You can manipulate it at the entire peering, right? We took the whole peering, and then we did it based off a prefix list, then we did it based off of an AS path, and then we did it AS path and a prefix. So that just goes to show you, you do have plenty of options when you want to look at weight and how it works. It's just one of those things you just need to understand what it is you're matching on and all that good stuff that goes along with that. So hopefully that made sense, and having a trace route to justify my point definitely helps. Now what's cool about this is I can go and manipulate this. So I'm not going to do it in this video because I want to do a video per best path mechanism. But what I could do is, I believe it was 68. When I'm looking at this, the way that the AS path is tracking, let me go ahead and scoot this over here so you guys can see this a little better. Pull up PC68 again. The way that we're tracking is we hit 26, then we go to 42, then we go to 62, then we go to quad 8. Now, let's say for example I didn't want to do that, but I'm like, I can only affect what I'm doing in this service provider. But what I could do is I could say I want, instead of 26 going to 42, and we're not going to do this in this video, I'll do it with local preference because it's like the next one out. I go 26 to 60 instead, but I had to set the local preference for the quad 8 prefix to do that. And I'll show you guys how to do that as well. It's actually pretty straightforward. You do the same thing with AS path prepending. I can say, I can set AS path prepends out so traffic goes this way instead. So there's lots of different ways that you can manipulate the routing table, and I want to show you guys what those look like. So it'll make a lot more sense when we get there. But I just want to give you some examples of how we could do that in terms of best path selection. So that is pretty much it for this video in terms of manipulating weight via, attaching it to the, I'm going to keep that in play so you can see what it would look like from multiple perspectives. But as you can see, it's not really that difficult to follow. So we'll take a look at all the different variations to see what we can do, what we can affect, and see how they come into play. But at the end of the day, the ones you care about the most for the majority of your testing is going to be local preference and AS path prepending. Those are the ones that are going to be able to do you probably the most for the most part. Those are going to be the ones you're going to want to focus on. So if you guys have any questions, comments, concerns, drop that into the comment section below. If you haven't already done so, please like, share, and subscribe, and I'll catch all of you guys in the next video.